Welcome everyone, this is your math tutor Naresh. In this tutorial, this is still Introduction to Algebra, we're going to learn about exponent rules. So I'm going to teach you 3 exponent rules. So let's get started. The first one is, so if I'm multiplying 2 to the exponent 3 times 2 to the exponent 2. So here I am multiplying base 2 raised to the exponent 3 and base 2 raised to the exponent 2. So I am multiplying same bases. The base is 2 and the first base has an exponent of 3 and the second base has an exponent of 2. So when we multiply with same bases, we end up adding the exponents. So that's the rule. So the answer here is going to be that this equals 2 to the 3 plus 2. So when we multiply with same bases, we add the exponents. So the exponents 3 plus 2, and which gives us 2 to the 5. So that's the first rule. When you multiply with same bases, you add the exponents. So now let's actually prove that that is true. So this is the question we were given. So what is 2 to the 3 times 2 to the 2? So let's apply the definition of the exponent. So what does 2 to the 3 means? 2 to the 3 means multiply this base 3 times. So that's the definition. So we're going to do that. So 2 times 2 times 2. So 2 to the 3, this is what we get. And now times, what about this? This is 2 to the 2, so meaning multiply this base, which is 2, twice, because the exponent is 2. So we go 2 times 2. So once we expand this, this is what we get. And now we can actually put this back into the exponent form. So now we have 2 that is being multiplied. So how many times is it being multiplied? So the base is 2. It's being multiplied 5 times. 1, 2, 3, 4, 5. So the exponent would be 5. So what you want to compare is that we get 2 to the 5 here, and this is what we stated up here. So the rule is, when you multiply with same bases, you add the exponents. So that's rule number 1. And I can generalize this. So if I have, let's say, a variable x and it has an exponent of a, or actually I'm going to use different letter for the exponent. I will use the letter m. So m in this case represents an exponent. So times, if I have another base, it has to be the same base, base x, but now has an exponent of n. So what this will become is x to the, so we're multiplying with same bases, we add the exponents. So this is going to be m plus n. So this is our rule number 1. So the rule number 1, when we multiply with same bases, we add the exponents. Okay. So I'm going to write this rule on the side here. So we have x to the m times x to the n. This equals x to the m plus n. So that's a rule. So now we can do some examples. So what if we're given x to the 2 times x to the 5? So what does that become? So here if we follow this rule, so our base is x, but our m is 2 in this case and n is 5. So when we multiply same bases, we will say this will equal, so still base x, but we add the exponents. 2 plus 5, so this will give us x to the 7. So that's the answer. So let's do another example. We can use different variables, different letters. So let's say if we have a squared times b times a to the 4 and times b to the 3. So if we have something like this, notice we have we have same bases, a to the 2 and a to the 4, but when we look at b to the 3, the base is different. So in this case, again, it's a similar concept as collecting like terms. So we have, when we multiply with same bases, only then the exponents get added. So what we're going to get is a to the 2 plus 4. So we're multiplying the same base as a, so we add their exponents, 2 plus 4. And what do we do with b to the 3? We copy it. It just gets multiplied as b to the 3. There isn't any other base b term that is being multiplied, so this just gets copied. So at the next step, we can simplify the exponent. So this is a to the 6, b to the 3. So that's the final answer. Okay. So now let's look at rule number 2. So the second rule is, what if we divide? So let's say 2 to the 5 divide by 2 to the 2. So this time we'll divide, we'll use the same base. So here I'm dividing same bases. So what happens when we divide with same bases? We end up subtracting the exponents. So this will become 2 to the 5, take away 2. So this exponent goes here, and the exponent from the denominator base gets subtracted. So when you divide with same bases, you subtract the exponents. So the exponent in the numerator and the exponent in the denominator, so you subtract the exponent that is in the denominator from the exponent that is in the numerator. So simplify this. So this becomes 2 to the 3. So 5 take away 2, the exponent is 3. So when we divide, we subtract the exponents. So I can prove this to you. So let's write, what is 2 to the 5? According to the definition, it is 2 being multiplied 5 times. So once, twice, 3 times, 4 times, and 5 times. And now what about the denominator, 2 to the 2? So by definition, it means you multiply 2, the base 2, twice. And now we can reduce. So this 2 will cancel with this 2 will cancel with this 2, and what are we left with? So we're left with 2 times 2 times 2. And now can we put this back into the exponent form? So the base is 2, and how many times is it being multiplied? 3 times. So the exponent on this would be 3. So now compare this, 2 to the 3, and this is what we got here, 2 to the 3. So this is our proof that when we divide bases, same bases, we end up subtracting the exponents. So now, in general, I can summarize this. So if we have base x raised to the exponent m, divide by base x raised to the exponent n, so I'm dividing same bases, then the exponents get subtracted. So it's x to the m minus n. So this is our rule number 2. Okay, so that's a rule number 2, and I'm going to write it over here. So x to the m divided by x to the n, this would equal x to the m minus n. So that's our rule number 2. Okay. Now let's do a couple of examples. So what if we have a to the 9 divided by an a? So this we're dividing with same basis. So subtract the exponents, 9 take away 1, so this will be a to the 8. And you can prove to yourself, in the numerator you'll have a being multiplied 9 times, in the denominator only 1a, and the 1a's cancel in the numerator and the denominator. You're now left with 8 a's being multiplied in the numerator. So 8a is being multiplied. How do you put that in exponent form? Base a raised to the exponent 8. So this is how you do this. Okay. Now let's do another example. So what if we have something like this? X to the 5 divide by a to the 3. So what if we divided this? The answer is can't be done, right? So can't be done, meaning you can't simplify this any further. This is already in its most simplest form, because when we divide, we can't just go subtract the exponents because the bases are different. The bases are not the same. Here we have a base of x, here we have a base of a, so the bases are different, so we can't apply this rule number 2. So the bases have to be the same, right? So the same thing with rule number 1. When you multiply with same bases, you add the exponents, only when the bases are the same. Rule number 2, only when the bases are the same, you divide, you subtract the exponents. Okay. Now let's look at rule number 3. So rule number 3. So let's say if I have 2 to the 2 raised to the exponent 3. So in rule number 3, we have an exponent raised to an exponent. So we have a power which is raised to another power, right? So when we have this, an example like this, we end up multiplying. So we multiply the exponents. So 2 times 3 is 6. So the answer is going to be 2 to the 6. So now let's prove to ourselves. So what does 2 to the 2 raised to the exponent 3 means? So we will start with the exponent, or the brackets, right? So here we're going to deal with what's inside the bracket. So here's the bracket, and then there is the exponent. So this exponent means multiply the bracket 3 times. So we're going to do that. 2 to the 2 once, 2 to the 2 second time, and 2 to the 2 3 times. So I multiplied this. Now at this point, I can apply rule number 1, because now I'm multiplying same bases. When I multiply same bases, I add the exponents. So 2 plus 2 is 4, plus 2 is 6, and that's what I get, 2 to the 6, right? So let's just say if you didn't want to use rule number 1, you could still go back to your definition of the exponent and do it the long way. So what does 2 squared means? This means 2 times 2, right? And what about this? That also means 2 times 2. And what about this? This also means 2 times 2. So now, can we put this in the exponent form? So we're multiplying the same base, so that's 2. And how many times are we multiplying? 1, 2, 3, 4, 5, 6. So 6 times, so it's 2 to the 6. So compare this, and that matches with what we said earlier. So this is my proof to you that when you have an exponent raised to an exponent, you can multiply the exponents together and you'll get your answer. Okay. Now if we go back to this step for a second, now here each base has an exponent, right? Each base, by default, the exponent is 1. So even at this step, we could have applied rule number 1, that when you multiply with same bases, you add their exponents, right? So that's exactly what we were doing. So 1 plus 1 plus 1 plus 6 times, so the exponent is 6. Okay. So now in general, so we can generalize this. So base x raised to the exponent m, and the whole thing raised to the exponent n. So this will equal to x to m times n. So that's our rule number 3. So that's rule number 3. So these are the 3 exponent rules. So I will copy this on the side here. So x to the m raised to the exponent n this will be x to the m times n. So I don't have to put a dot. It's understood the dot is there, that m and n are being multiplied. So these are our rules. So rule number 1, rule number 2, and rule number 3. So now we're going to do some practice. Actually, let's practice rule number 3. So 1 or 2 examples. So what if I am given x squared raised to the exponent 4, right? So this will equal, all I have to do is multiply these exponents. So x to the 2 times 4, that's 8. So that's x to the 8. Now, what about, let's say, if I have 2x to the 3 raised to the exponent 3. So in this case, now remember what's inside the bracket, the whole thing is being cubed, right? So now we have 2 bases inside the bracket. We have a base of 2 and then we have a base of x. So each one has their own exponent, right? So 2 has an exponent of 1. So what do we do in this case? In this case, we multiply 1 and 3 to get the exponent on base 2, and then we multiply the 3 and 3 to get the exponent on the base x. So this actually will become 2 to the 3 times x to the 9. So 1 times 3 is 3, that's the exponent on base 2, and then 3 times 3 is 9, so that's the exponent on the x. So the outer exponent, it applies to each and every base that is inside the bracket, right? So is everything clear here, right? So we have 2 bases inside the bracket, the 2 and the x, and each has its own exponent. Now bracket means the exponent that's on the outside of the brackets, that exponent applies to each and every base that is inside the bracket, right? And all you do is apply rule number 3, you multiply the exponent on the base with the outer exponent outside the bracket for each base, right? So now, could we do this using the lengthy way, like the very first things that we learned? So here we can say, okay, 2x to the 3 cubed. So I could write this 3 times, right? So 2x to the 3 times 2x to the 3 times 2x to the 3. And actually it's better to use brackets, right? So now what do I get? So 2 times 2 is 4 times 2 is 8. So maybe you were having difficulty figuring out where we got the 8 from. So actually I can simplify this further. 2 to the 3, 2 cubed is 8. So 8x to the 9, that would be the simplified answer. And now, so 2 times 2 is 4 times 2 is 8. Now what about x to the 3 times x to the 3 times x to the 3? So we're multiplying with same bases. Now we'll add the exponents. So x to the 3 plus 3 is 6, plus another 3 is 9. So there you go. So we get the same answer. Okay. Alright, so I'm going to erase. So now what we're going to do is practice these 3 rules, the 3 exponent rules. So I'm doing 3 videos on this tutorial. So in the first one we will concentrate on, we'll do some practice on rule number 1, and then in the second video we'll practice rule number 2. In the third video we'll practice rule number 3. Okay, so I'm just going to bring up some practice questions. So what about x to the 2 times x to the 3? So we're multiplying same basis, so we add the exponents, x to the 2 plus 3, so the answer is x to the 5. Okay, so now what about a to the 4 times a to the 2 times a? So here we have same base and we're multiplying. So remember, a here has an exponent of 1. So this becomes a to the 4 plus 2 plus 1. So this is a to the 4 plus 2 is 6 plus 1 is 7. So actually I'm going to stop this video here, and I'll continue in the second video where we will do more practice. So I hope you found the video useful. If you did, please like or subscribe, and thank you for watching. We'll see each other in the next video. Once again, thank you for watching.